All right, thanks for joining us back after the break. We have Cathey again. This time he's going to be talking about embracing a grid of the future. We will again take questions at the end if you have them. So with that, I will turn it over to Cathey.
Okay, so why were the wind turbines so happy? Because their life's a breeze. Har, har, har. Okay, I've got 4 kids, so I've a lot of dad jokes. Okay, we only got 30 minutes, and embracing the grid of the future is probably like a multi-day conversation or multi-year, or probably until we all retire. But I'll try to cover what we can and then save some time for the questions. You guys should know SPP, but I always like to start with these kind of, just to give a visual, because sometimes if you're not involved in SPP, just recognize the overall footprint. Now, this isn't our contract services that we do in the West. This is SPP, I would say full membership and SPP proper. So it gives you kind of indication. Now, we do have 2 DC ties to ERCOT, I mentioned from the winter weather event. And then we have 7 DC ties to the west. Okay, so some statistics. This is always good for the Wind and Solar Conference. Stats on wind and solar. 27.4 gigs of wind operational. So that's commercially operational and registered and operating in SPP's market today. Now, the bottom one is very interesting. We have 29.9 gigawatts registered in the market. And so when you're registered in the market, that means you have telemetry, you have testing. So this isn't a queue thing. We pretty much have 30 gigs. It's just they're not quite through the final operational aspects. So we fully suspect that this number becomes this number probably by the end of the year. It usually takes about 45 days once you've registered that you become operational. They're mostly 80 meter hub height, over 13,000 individual turbines, so it's a lot of wind. We have 11.6 gigs that are unbuilt with signed generation interconnection. So this is kind of a hot topic, right? We have a 3-year, almost 4-year GI backlog. You guys have heard this. You're probably involved in that. We are working diligently on our 3rd pass since I've been at SPP to be able to help clear the backlog. It's a problem we need to work through. We have recently gotten approval from our board, and we're working on a FERC filing to modify the GI process to be able to get out of the backlog and catch up to the generation in the queue by 2025. So in the next 3 years, work through that process and get out of the queue. There's a lot of things that need to happen. It's such as increase. There's some policies necessary to be able to incentivize resources in the queue to be able to stick with the process. There are some challenges with that because of the way FERC has written the rules associated with the open access transmission system. So we're trying our best to be able to do that. That said, we are processing. I mean, we have installed roughly, I looked at the last decade, we've installed 2.8 gigawatts of wind every single year for 10 years. And so yes, we have a backlog, but the GI process has never been designed to have a wholesale fuel mix change. It was designed 20 years ago for incremental gas or a peaker unit, or just I want to build this particular resource I'm going to. And so we're working with kind of an archaic design that we're trying to modify, and we're also working with FERC to be able to try to do that as well. So we're working diligently, but I can say there's another 11 gigs, so we're at 29.9, another 11.6. We've got a lot of wind. I mean, it's coming, and it's there as well. So some of the stats, our output's 21.1, so we have 27.4, but this was our output record back in March. Our minimum output, now this is a problem, I've mentioned this before, is we've had a low wind as of January of last year at 252 megawatts. I was going to ask y'all a quiz, but I already skipped to the slide, so y'all know the answer. What is our low wind output? It's 252. That's not a lot of wind when you consider how much we have installed. So it still continues to be a challenge. Wind is a great resource, but we need to make sure that we're continuing to build other attributes to be there when the wind isn't. it is amazing to me, that we have such strong wind, but sometimes the wind is just not there across 14 states. It's not just Nebraska. It's the whole region. The wind's just not blowing. That's pretty wild to me that we have periods like that, but we do. Mentioned the swing. So this is another aspect. This is not regulation. So some people say, I think the general public thinks wind is kind of an intermittent resource, like all of a sudden it stops. It's not really that much from a regional perspective. It's more what we call a slow burn in operations. So we slowly burn thousands of megawatts across hours of time. And so the question is, what can we do to be able to bounce that out? And most of the time it's gas. It's what we replace it with. So this is our queue. So you've got solar for the first time this year. We have solar we have more solar in the queue than wind for the first time ever. And so solar is kind of our next frontier at SPP. We only have 250 megawatts of solar installed today. A lot of that is locked up in our queue. So that is another aspect that's really important for us to get out of the backlog so that it can get installed. And just rough estimates, if we have the GI process through the backlog, we should be at 4 to 5 gigawatts of solar in the next 4 years. I mean, that's a pretty big jump from 215 megawatts to 4 to 5 gigs of solar. Storage, this is huge. So here's a quiz. This will be fun. FERC Order 841 came out, and it was the Electric Storage Resource Order. Can anyone tell me how much storage was in our GI queue when FERC Order 841 came out? It's FERC Order 841. 841 megawatts. I don't know why. It's such a coincidence, and it's really stupid, but I get, I'm a nerd like that. So I thought it was funny that's exactly how much was in our queue when the FERC order came out. But we're nowhere close to that anymore. I mean, so that just kind of tells you that wasn't even but a couple of years ago, and now we're at 13 gigawatts. So a lot of that is coupled with solar, wind, or both. We actually have some that are the trifecta of wind, solar, and battery all at the same site. What's interesting to me is about a third of that is standalone. And that's kind of interesting just because I've talked to a lot of the battery developers, and it does, even though batteries continue to be cheaper and cheaper and cheaper, it still requires a number of you have to build the business case, and you have to have reasons to be able to build it, and it still requires some level of capacity or ITC or so forth. But obviously there is still a business case in our region to build standalone storage right now as it speaks. All of this technology is lithium ion. That's interesting too. We have some level of gas, and then we actually have hybrid, which is kind of carved out from this specifically because of administrative reasons. That does not mean there is actually some hybrid that is kind of mixed between these numbers as well. Anyway, it's just to illustrate. We peak at 52 gigawatts. Our valley is 19 gigawatts. So when you talk about just what's in the queue, 99.7 gig. I mean, we have almost double in our queue than what we even have as peak load. So I mean, we've got a lot of renewables that we're trying to move through and interconnect. It's pretty fun, but it's also somewhat stressful because we obviously are under certain deadlines and expectations, and so what we're trying to do is modify the process to be able to adhere to the baseline core reason why we do interconnection is to make sure that when these resources actually operate, they operate reliably, and we identify the upgrades necessary for them to interconnect, and we don't have unintended consequences later. And I'm learning a whole lot from, inverter-based resources bring a different type of issue to stability on the system, so we have to be able to assess that. So there's a lot that actually goes in the GI process. I brought this up last screen, but it just sets the tone as far as the embracing the future. What we're attempting to do at SPP, and I mentioned, is outline and graph the retirements, outline the new resources, and try to identify the particular attributes. I mentioned that last time. I'm not going to go through all this. I did leave this in here for content. but it is our updated strategic plan. There are a couple of things that I wanted to highlight, though, such as the strategic opportunities where we're optimizing the seams, western expansion, innovative transmission planning, and grid of the future. So part of the topic name is grid of the future. And so what we're attempting to do with this particular initiative is identify all of those things that we don't know and try to back those up. And from a policy perspective, you can't build transmission. I mean, it takes 4 to 6 years to build a transmission line from the point that you actually identify that you need it. And so you back up from that, it takes about 2 years to identify that you need it. Capacity is the same way. So these things take a long time. You can't just build a transmission line or build a generator. So we need to make sure we're projecting properly and building the transmission system out and projecting for this stuff. I left this in here because this is our corporate objectives. Some of the things that are very interesting, I think, from a wind and solar conference perspective is the 20-year assessment. So we're working on every 5 years we do a 20-year assessment, and we're in the middle of doing that 20-year assessment. We're supposed to be complete roughly December of next year with our 2042 projections, and we're looking at 4 different futures, kind of like a bookends on where the grid's going from a transmission perspective, generation perspective, so that'll be really helpful. Order 2222, that might be, I guess, important to the Wind and Solar Conference because it's distributed energy resources. That's kind of interesting. We've got Walmart and Target and other entities that are they're interested in pursuing the distributed energy resource or aggregate retail customer type of approach. And of course, our grid of the future in that endeavor. This particular initiative is going to be another stakeholder-driven process. So we're standing up a task force and having stakeholders drive this particular effort and initiative and make sure that we're basically capturing everything that we need to capture to work through to be able to adhere to the overall strategic goals of the next 6 years. So I'm going a little bit fast because we don't have a whole lot of time, but I wanted to make sure I covered a couple of topics, key topics before questions. This right here, I know it's a busy slide, but it does, I just want to highlight, we have 4 futures. This one, which is interesting, this is kind of like the Biden plan, even though we scoped it before he was elected. We said, okay, let's do the kind of the bookends of where we're going to be in 20 years. And this was a highly accelerated decarbonization plan future, and this one is basically the same future, but with zero hurdle rates with MISO, so it's kind of like a seams type of sensitivity. What I wanted to highlight is this bubble is when you talk about year 20, that's based on 20 years from when we finished the study. So we started scoping it last year. It takes about 2 years to do these studies. So you have to do it in reference from 2022. So it's 2042 is the target year that we're looking at. And so this is where we're projecting these particular futures: 65 gigawatts of wind and 48 gigawatts of solar. So what is that? 113 gigawatts of installed capacity. We've got 99 gigawatts, 99.7 gigawatts in the queue. We've got roughly 30 gigawatts that are registered. So we're already at 130 based on what's in the queue today and what's installed in wind. So, is this out of the question? Is this, so just looking at, maybe it's not going to be 2042, maybe it's going to be 2050, but this is where we're kind of looking at. And what's going to be insightful is we don't issue notice to construct for 20-year assessment, so no transmissions built out of this study. But it is very important because what it does is it gives a guideline for transmission planners to understand, if we're starting to build transmission 5 years out, is it starting to get built out to be able to meet an ultimate longer-term goal, such as, really all 3 futures? And what is the likelihood of any of these actually happening? Who's to say? That's the million-dollar question. So I like this because it helps illustrate visually what we're talking about. So you have the F1, then you have the GIQ. So this is the Q of this solar projections for 5 and 10 years 5 and 10, and then we project out, extrapolate out based on the year 20 values. So we're kind of looking at various, out of the queue, what is going to be built when, and you back in from that. And what we do in the long-term transmission plan is we look 5 and 10 years out, and we try to optimize all the needs of the futures, all the needs of the years, and then we try to optimize the transmission system that would cover all the bases and say, okay, is it good? Is it valuable? Is the benefit-cost ratio valid? And then we issue the right transmission. Skipped again. This is the wind projection, so it gives you kind of an indication of 2032, 2034, where wind is. This is the wind queue, but as you can see, it's a little bit tapered off based on historical record of what we've actually seen being built out of the queue. Okay, so we have retirements. These are transmission planning considerations. So building the grid of the future, embracing the grid of the future. Electric vehicle storage is very interesting. We actually did a really deep dive. I think one of our engineers did a great job looking at state sales and looking where the investments are and where the projections are at the individual EV investments are actually happening, and looking at the projections by state, rolling it up to SPP, looking at the load, looking at all the charging stations. I mean, we had a number of things that are going through it, and we try to build that into the assumptions of the transmission system and models. Electrification, decarbonization is the same thing. How can we understand where the electrification trends are going, where the energy efficiencies are going, and try to predict that? Now, a lot of this is member-driven. All of it's member-driven in terms of all of our members have a say in these particular assumptions and making sure that they're valid and reasonable, because ultimately, if you guys are going to, if Nebraska, for instance, is going to pay for some portion of the transmission portfolio, you need to be comfortable with the assumptions that we're actually projecting 2, 5, and 10 years out for our NTCs. Advances of technologies, renewable additions, very important. Energy demand growth, we mentioned that. There are certain pockets that are growing pretty quickly, but overall it's mostly energy that's growing and not necessarily peak. Retirements, that's another one that's very interesting, because I don't even know that all the utilities know their retirement plan. They're trying to figure it out. They're trying to figure out their resource planning and their retirements. But the sooner that we know the retirements, we can model them and then understand what's replacing them. One of the challenges we're actually having is, just y'all tell me, I'll just make this a little bit more interactive. Where's the wind and the solar generally being built? The west side or the east side of the footprint of SPP? No, west. So where's the load generally? East, right? So Omaha and Kansas City and Tulsa. So what we're seeing is the retirements are actually happening on the east, and all the new generation is happening on the west. Generally, I mean, it's peppered around, but generally all the new generation is on the west, and all the retirements are happening on the east. All the load is on the east. So what we're seeing is voltage stability issues, angular stability issues. We're seeing harmonics issues. We're seeing very electrical engineering specific type of issues that really traditionally hadn't been an issue before, because when you had generation and load that are kind of close and peppered around across the region, you wouldn't necessarily see those. You'd see thermal limitations. There were traditional conductor limits or terminal limits. But that's something that's kind of challenging for us from a planning perspective, because then the question is, okay, these utilities may be retiring conventional resources, adding solar, or maybe purchasing from solar to be able to meet their resource plan. But then who's to say that they aren't converting that resource into something else, or maybe they end up building something later? And so then the question is, how much do we actually upgrade the transmission system to be able to adhere to the heavy west to east transfer if the members are going to turn right around and maybe build something in its place? Maybe it's more renewables, but it's on the east side. And so we're trying to balance all that and make sure that we're actually building appropriately and in time for what's happening. Let's see. Okay, so traditionally we've actually had wind. So this is enlightening to me. The years of the ITP, our integrated transmission plan, our long-term plan, is based on the year that it ended, not the year that we started it. So 2 years prior to 2019 was 2017. We set the assumptions for the long-term plan. Well, when we set the assumptions, we predicted that the wind in 2029, this is our kind of, I would say, our aggressive year, is at 30 gigs in 2029. Well, where are we at now? It's not even on the thing. How much it's a quiz. How much do we have registered in the market? 29.9. So we're already at 2029 levels. And what year is it? we're 8 years ahead of what we actually predicted just 2 years ago in the portfolio. So it gives you kind of an indication that we've been kind of conservative we have been conservative on the wind projections. It's rightly so, though, because some of this wind doesn't get built, and you don't want to build millions of dollars of transmission and the wind doesn't show up. But what we're starting to see is that trend is continuing to grow, and the reality is this wind and the solar is getting built, and it's starting to get caught up in our transmission plan. So you can look at this as glass half empty, but then you look at glass half full, we're catching up. So you look at our assumptions, and we're obviously assuming more and more wind and solar in our particular transmission plan. So we're catching up to what we need to project for. Here's a quiz. Does solar happen at night? No, what was funny is we actually had an engineer find in our economic model one time that solar was generating at night, and that was a problem. Because, it's intuitive with this solar generator. Why is it generating the model at night? So I guess it does happen. You just got to catch it. ELCC, I think the way to explain this is how likely is the resource going to be there when we need it to be there? And the percentage kind of tapers off as you increase the amount of wind or solar that's installed. Well, if you look at our solar profile, we actually do have a pretty decent solar profile, especially during the summer. And so roughly the first 8 to 10 gigawatts of solar is going to be valued very high, because the first 8 to 10 gigawatts that's going to be installed is going to be valid during the day when the peak has that kind of sine wave approach. But then after that, it's almost negligible, and that's why it starts tapering down pretty quickly. And then the winter, it's very low. And so what we're trying to do is understand what we're really attempting to do at SPP is value these resources as much as we can, but without going overboard, and making sure that we're not overvaluing the solar or the wind. And now we're running a grid that is not reliable 20% of the time. We need to make sure that it's reliable 99.9, 4 nines out. Batteries the same way. I mentioned it last time. We settled on a 4-hour capacity, and that's pretty traditional or standard, at least right now, of what's actually in the queue is 4-hour batteries. And then we talked about the performance base. So I think one thing I wanted to talk about real quick, if I had like an extra minute or two, was something that's novel, and this is called the Joint Targeted Interconnection Queue. And so we run coordinated system plans with MISO. It's interregional projects. And so what we do is we try to understand what would be the benefit along the seam. And why is this important in Nebraska? Well, so this is a good example. This just happened in September. So it's a really good example of what was happening and what we're actually studying and planning for is you've got some congestion. It's north to south. Congestion based on the pricing is low here, pricing's high here. So you're basically saying back down generation here and increase it here. So there's a prevailing flow that's going north to south through Nebraska into the east side. And so what we're trying to do is work with MISO and say, okay, what's impacting them in kind, and so can we upgrade the system? So what we've identified is a number, if you can see, I wish the states were on here, but you could see kind of the location of the upgrades in the transmission in Minnesota and Iowa and so forth. It's along our seam of different transmission upgrades. And what we're trying to do and why it's novel, this is into Omaha, is we're trying to get SPP and MISO and the interconnection customers of SPP and the interconnection customers of MISO to pay for these upgrades. So it's basically four areas. So it's, traditionally it'd be just SPP load and just MISO's load. What we're trying to do is say, okay, why would generator interconnection customers do this? Well, there's a backlog, and some of this is clogged because there's there needs to be upgrades. Well, what we're trying to do is optimize it to where the interconnection customers are no worse off by paying some of the upgrades. They get to interconnect quicker, and the load benefits because they're economic projects as well. So it's pretty novel. We've gone through the engineering exercise. Now it's kind of the human exercise of cost allocation and financial business aspects. I know I'm running out of time, but there is one other thing I wanted to mention. There's market stuff. Maybe we can save it for the next time, but one thing I wanted to mention is this. So we have something called Script. It's SPP's Creative Reengineering of Integrated Planning Team. I didn't come up with the acronym, but it's called Script. And so in a nutshell, what it is we have different business functions like AQ. AQ is when OPBD or NPBD or LES has a load and they want to transfer a load to a different transmission spot, or they want to add a load. Maybe there's a data center that's coming on. They want to add a load. They go through transmission service process. Well, then GI, we talked about GI. You're a generation interconnection. We understand the backlog. You're trying to interconnect. You go through that process. Then you have this middle part, this integrated transmission plan. What we try to do is we identify reliability needs, economic needs, public policy needs, and persistent operational needs, and we try to optimize those 4 needs for a single grid. We have a single grid. That's the thing. We have multiple business functions and reasons why we do those things per the tariff and per our rules that we all agreed on and FERC agreed. But what Script is about is trying to optimize those into a consolidated study. And so for the integrated transmission plan, for instance, as an example, is when we add all those wins to the model, we have to put them somewhere. Well, we use the GI. We're basically doing the GI process in our long-term transmission plan. We even calculate the upgrades necessary to facilitate those fictitious wind or solar in the long-term assumptions. So why can't we just turn around and make it a financially binding study, allocate those upgrades to the customers, and then we're optimizing this. We're optimizing the transmission system. We're optimizing the GI process. Now, this is a great thing, and it sounds great, but we have to get out of the backlog. So be following that. I can give updates throughout the next few years. We're targeting the first consolidated study in 2025. Sounds like a long way away, but I mean, we got a lot of work to do, and that's going to be a very successful study if we can pull that off. So I know I covered a lot, probably too much for 30 minutes, but do we have some questions or?
Hopefully this will be fast. In the futures plan, that was the SPP footprint as it is right now, right? I'm
Correct.
guessing. And what was the projection for demand? For
Demand for load demand?
Yeah.
I would say it's 1% to 3%, but it's based on the individual utilities, and they tell us the load forecast, and then it rolls up to the overall region.
Sorry, is that for the future 3 with the aggressive?
Yeah.
Okay.
Yeah, it was in the box, but it was very small. All right, thank you.